Hey there, listeners. If you enjoy listening to the Everything Weather podcast, make sure to subscribe and leave a review. Your thoughts help the podcast grow and bring you even more amazing episodes filled with weather insights, stories, and fun. Also, a quick shout out to Yellow Dog Coffee Roasters. More on them later in the podcast. Thank you for listening, and now to the episode. Hello and welcome to the Everything Weather podcast, where we talk with people about the weather world, explore and discuss everything weather, and have a little fun along the way. I'm your host, Kyle David, and today we're excited to have Dr. Alyssa Stansfield on the podcast. Dr. Stansfield is an assistant professor in the Department of Atmospheric Sciences at the University of Utah, specializing in tropical weather, precipitation, and climate modeling. Hi, Dr. Stansfield, and welcome to the podcast.
Hi, thank you so much for having me.
Absolutely. Before we get into your weather story, talk a little bit about what you do at the University of Utah, I've got a fun game for you.
Okay.
We've got rank these. So I've got a weather-themed and a non-weather-themed one. I'll give you the weather-themed one first. Rank these 5 cities based on their weather. So you can blindly rank each of these cities from 1 to 5, 1 being the best, 5 being the worst. First up, Salt Lake City, Utah.
Ooh, I do like Salt Lake's weather so far. It's a little hot in the summer, but I don't mind the heat too much. Right now it's really cold, but I tend to like the drier winters. So I'll go 2.
Okay, 2. That's interesting. You like the winter weather out there?
Yeah, I mean, I'm a skier, so I do like some snow, especially when it's in the mountains. And I just like the dry winter better than the damp winters in the Northeast.
That's fair, and that's ski country, so you're in a perfect spot out there.
Yep.
All right, next up, Tampa, Florida.
Ooh, okay. Yeah, definitely humid. I grew up in New Jersey, so I'm used to the humidity. And yeah, I guess I don't mind the heat that much, although it probably get annoying after a while. So yeah, I'll give it a 3.
Okay. So we have Salt Lake City 2, Tampa 3. Next up, Portland, Oregon.
Yeah, so I've never lived in the Northwest, Pacific Northwest, but I think the constant cloudiness and like drizzly weather would get me down in the winter. So I might give it the 5.
Oh, poor Portland, Oregon.
Yeah.
To be fair, I think I'd probably put it 5 too. I don't like wet, dreary weather constantly, so I'm with you on that one. Next up, Chicago.
Ooh. Okay. Pretty cold. It can't be my 1, so I guess it'll have to be the 4, and I don't know what I'm getting for the 1 now.
That's the fun of this game. All right, give the number 1 spot to this remaining city. Philadelphia.
Okay, near where I grew up. I'm from New Jersey, from Wall, New Jersey. So, although it's maybe not my favorite, I like Salt Lake City weather now. I'm okay with giving it the 1.
Yeah, it's hometown weather, so you're familiar with it. So it's not like you put Portland, Oregon at number 1.
I know what to expect.
Definitely. All right, I've got one more for you. This one is non-weather themed. Rank these 5 breakfast foods. So first up, we have pancakes.
I like pancakes, especially like chocolate chip pancakes. Those. Yeah, I'll give pancakes a 2.
Ooh, strong 2. All right. And there's a good pancake place. I don't know if you know it in Princeton called PJ's.
Oh, I haven't spent too much time in Princeton, so I haven't been there.
Well, if you're in New Jersey, I recommend it.
Okay.
All right, next up, bacon.
Oh, bacon's pretty good. Yeah, it's so salty. It really hits the spot sometimes. I might have to give that the 1.
Wow.
Yeah.
Okay. Give bacon the number 1 spot. All right.
Yeah.
Hey, that's fair. All right, next up is oatmeal.
Ooh. I actually do eat oatmeal in the morning a decent amount. I like to put some fruit on it, but it's like not the most exciting thing. So let's go 4.
Okay. Next up is scrambled eggs.
Yeah. Eggs are okay. I feel like they're very like solid, like filling. I guess I'll give them the 3. I don't think I used the 3 yet.
No. So you put them above oatmeal.
Yeah, I think so.
All right, so that leaves the number 5 spot, and unfortunately, it is bagels.
Ooh, yeah, bagels are so fun fact is my high school job was working at a bagel store. Every summer for like 5 or 6 years, I worked at the bagel store over the summer.
Really? Okay.
So bagels probably should be higher for me, but oh well.
If you could swap one of them, would you put bagels at one?
Ooh, maybe they'd go two, and then bacon and bagels go together. You know, bacon, egg, and cheese.
With salt, pepper, ketchup on that?
Yeah.
Oh, for sure. Now you're making me hungry. All right, let's stop talking about food and get into more about the weather. So, everybody I have on the podcast, I talk to them about their weather story, which in the business we talk about the day's weather, what's the day's weather going to be. But for this, I'm interested in learning more about each person's upcomings and how they got interested in the weather. So, Dr. Stansfield, tell me, what got you interested in everything weather?
Yeah, so my weather story goes back to probably my senior year of high school, actually, which was 2012. And so that was the year that Hurricane Sandy hit New Jersey. And so I grew up in Wall, New Jersey, and I'm really close to the beach. After Hurricane Sandy hit, thankfully my house and our stuff was okay, but I knew a lot of people that did get displaced from their homes and lost cars and belongings and stuff. And also we were out of school for 2 weeks after Hurricane Sandy because of the travel disruptions, flooding, power lines, trees. So that really made an impact on me. And so my senior year of high school was also when I was like thinking about what to major in college. At that, being just interested in Hurricane Sandy, and I was like, oh, is this to have to do with climate change? Is this going to happen more in the future because of climate change? Hurricanes hitting New Jersey, that's relatively rare. And so, yeah, I saw that Rutgers had a meteorology program, and so I just thought that was really cool. And so that's what made me choose my major. I was always interested in science. I thought for a while I wanted to maybe major in like marine biology or oceanography or environmental science maybe. So I was always going to do something sciencey. But after Hurricane Sandy, that was what really piqued my interest in doing meteorology.
I'm curious, what made you stay in the Garden State as opposed to going outside of New Jersey for just study meteorology?
Yeah, I like being close to my family. I lived at Rutgers, but I was only a 50-minute drive, which was nice. I also got a scholarship to go there, so money always helps. About 50, maybe an hour from Wall to New Brunswick, yeah.
All right, that's not a terrible commute. But going back to your story with Hurricane Sandy, I want to talk about that a little bit for a second. What was that experience like for you being down there in Wall, New Jersey, pretty much close to the shore, getting to experience a rare phenomenon for the state of New Jersey?
It was really interesting and sad in many ways. So my house that I grew up in was about a 5-minute drive to the ocean, so it really is pretty close. Thankfully, my house is on a hill, so we didn't get any flooding, or we had a couple trees fall down. Thankfully, none hit the house. But first of all, we lost power for a couple days, I think 3 or 4 days. We didn't have power, so our refrigerator wasn't working. We had to try to keep things cool. I remember my dad like grilling up all this stuff because you could just use the propane grill. And we had to use candlelight like at night, so we went to bed really early because you can only do so much by candlelight, no TV or anything. And then after a couple days, like we got our power back, thankfully, and I was able to go see my friends. And I remember going to my friend's house who lived in Point Pleasant, New Jersey, which is a little south of me and even closer to the ocean. And we were walking around a little bit. Stuff was still flooded. I remember seeing so many boats on people's front lawns because the water just rose so high, it drifted the boats onto people's front lawns that were not even anywhere close to the water anymore. So I think just seeing those impacts, on people's real lives and just my life being impacted maybe even in a small way, like not having high school for 2 weeks, it was pretty crazy. And so, that just got me really interested in it, and just not even hurricanes, but just the weather in general and climate change and how these weather events may change.
Yeah, I think Sandy influenced a lot of people to go into some sort of sciences or emergency management. I could definitely say that was the case for me. That was an influencing factor. Now, in the intro, we had talked about you specialized in tropical weather. Would you say Sandy influenced you in the direction of studying tropical weather more?
Yeah, I would say definitely so. I knew I wanted to go to grad school. I specifically looked for professors who did research involving hurricanes because that's what got me interested in the atmosphere and meteorology. So I was hoping to get to study hurricanes in grad school. And thankfully, yeah, I found my PhD advisor at Stony Brook and ended up doing research on hurricanes.
So you went from Rutgers to Stony Brook, and now you're at the University of Utah. You've been all over the place in terms of your studies. What got you interested in going to Stony Brook and then eventually to the University of Utah?
Yeah, so I knew when I went to Rutgers, I just knew I wasn't too interested in broadcast meteorology. I just felt it wasn't for me. And then we got to practice forecasting a lot in our classes at Rutgers, like doing the weather challenge. And I think at some point we were even kind of forecasting for those locations for grades. And so I got to practice forecasting for various locations around the U.S. for the next day, couple days. And I think in doing that, I also realized that day-to-day forecasting also wasn't what I really enjoyed. I think I would have been fine if I ended up doing that, but it just didn't get me super excited. So then I ended up doing some undergraduate research with Dr. Ben Lintner at Rutgers, because he was my undergraduate advisor. I got to do a little bit of research on moisture in the tropics and profiles of moisture. And so getting that research experience opened up that world to me of, oh, hey, you can do research for your career. That seemed really exciting to me. And so that's why I ended up applying to go to grad school.
Now, real quick, before we get into more about your research experiences, I want to go back to the weather challenge, the forecasting challenge that everybody who's studying meteorology has to take part in. They have to forecast for a location for, I think it's like 2 weeks at a time.
Yeah, something like that.
What would you say is your best and worst forecast with the forecasting competition?
Oh, gosh. I don't remember it too well. I'm going to be honest, I wasn't good at it was the other thing. I just didn't have the natural kind of talent at it. So one location I particularly remember we were forecasting for was somewhere in western Nebraska. And we all did really bad forecasts because we didn't realize how quickly the winds can pick up there. So the winds were so fast. And I think all of us forecasted it really bad. So that may have been my worst one. But yeah, that's the one I remember specifically. But like I said, I wasn't super excited by it. And I also wasn't very good at the forecasting. So I think that kind of deterred me away from doing that as a career.
If it makes you feel better, when I did the forecast competition, we also did a location. I think it was Scottsbluff, Nebraska. Mm-hmm. We also all struggled because of winds would pick up so quickly.
It may have been Scottsbluff. Yeah, I don't remember exactly where it was, but
yeah, that and Saginaw, Michigan. There was a winter system, and winter forecasting is a lot of fun depending on how you look at it.
Oh yeah, it's tough. I mean, I respect the people who do it because they do it really well and way better than I could do it.
For sure, it's a lot of different moving parts and stuff. But going into your research and going to Stony Brook, what did you learn there during your time at Stony Brook that you transferred over to your time in your current position at the University of Utah?
That's a good question. I learned so much. Going to Stony Brook was exciting. It's a good atmospheric science department, and they have people who do research in a lot of different things. So I got to learn and take classes from these experts in so many different topics related to not only atmosphere and meteorology, but there were people who did oceanography research and interactions with other parts of Earth's climate system. I also took a tropical meteorology class, which was really exciting to me because I went to research hurricanes and I got to learn about not only hurricanes, but other types of tropical waves and why they form and move the way that they do. And I thought that was really cool. And I think another thing I learned was when I went into grad school, I knew I liked hurricanes, and I originally thought I wanted to go try to work for the National Hurricane Center after grad school. I thought that was the career way I wanted to go. In going to grad school, what's cool is you get to go to these conferences. So the American Meteorological Society annual conference, where all these experts get together and give presentations, and you can meet people from so many different universities and companies and organizations. And so I actually got to, at one of those conferences, talk to someone who worked for the National Hurricane Center. And he said that about half of their year is like forecasting, and they do shift work in forecasting the hurricanes. And then the other half is they leaned a lot into public communication and improving people's preparedness for hurricanes. And so knowing that, then I realized I was like, oh, I don't really know if I want to do forecasting and shift work with forecasting 6 months of the year. Because again, even though it was forecasting hurricanes, which I'm interested in, it was still forecasting. And yeah, shift work means you have to stay up all night sometimes. And I'm not a night person, I'm a morning person. So I didn't know how that would work either. So then I realized, okay, maybe working for the National Hurricane Center, at least as a forecaster, may not be the path that I want to go down. And so then that kind of got me interested in other careers, and I thought about going to work for like NOAA or NASA or NCAR, the National Center for Atmospheric Research in Colorado, or being a professor. And then I realized I liked working with students, so I got to mentor some undergraduate students during grad school, and also as I progressed through grad school, I got to help the younger grad students in my group with coding problems and any class questions and stuff like that. So I realized I liked mentoring and helping students, and so that kind of got me interested in becoming a professor. So after grad school, I applied for a postdoc position, which is basically like a continuation of doing research with Kristen Rasmussen in the Department of Atmospheric Science at Colorado State. And so that's where I began to make my journey west in the U.S., and I lived in Fort Collins, Colorado for 2 years, and then got my job here at the University of Utah.
Interesting. So real quick, what made you want to change from Colorado to Utah?
It was just where the job was available. I really liked Colorado and Fort Collins as well, but Salt Lake City is better for skiing. We're closer to the ski resorts here and the hikes and everything. And it has a similar climate to Fort Collins, but it's like a bigger city, so it interested me as well. So basically I applied for the job because it was open and ended up getting it. So
it was just a chance opportunity that you got into Utah?
Pretty much. I mean, so professor positions sometimes are hard to come by. Like they only tend to open up like maybe when someone retires or the school gets funding for a specific topic. So you have to be a little bit open if you want to be a professor to like where the jobs are available.
Now, I'm just curious, would there be a place that you would not want to go?
I generally am not too interested in going to the Midwest. Generally, I think it's too cold for me in the winter, too cold and windy. And I don't really have any family there or anything. So that was a region that I wasn't as excited to go to. I'm more of a mountains or beach kind of person.
Not many beaches out there in Utah, I'll say.
No, but lots of mountains.
So it makes up for it. Okay. But I'm curious about the academia landscape because you're the first person I've talked to on the podcast about research and academics. What does the day-to-day look like for you?
Yeah, the day-to-day is pretty different every day, and it depends on the tasks or due dates I have coming up. So I started my position as an assistant professor in August of 2024, so I'm still pretty new. And in the fall semester this year, I didn't have to teach. So my job was getting spun up on all the university systems and obviously meeting the other faculty members in our department and in the university, and also writing research proposals for grants, because that's how we fund graduate students and get money to do our research. So that was a lot of my day in the fall, was really doing work, writing these research proposals and doing background literature reviews and stuff like that. And then this semester I started teaching. I teach my class every Tuesday and Thursday, so that takes a lot of preparation, making sure I have all of the lectures ready and the exams and homeworks. And then also thinking about writing more research proposals. I always have to be doing that as a professor. And I'm also working with 2 undergraduate students who are doing some research project with me and working on recruiting grad students as well. So As a faculty member, we wear a lot of different hats. We're teachers, we mentor students, we have some committee work where we have to sit on committees for our department and for the university. And then we also write research grants and do some research as well. So it's a lot. And every day looks different.
Yeah, that sounds like a lot of different hats that you're wearing. And I want to explore that a little bit later, but I actually want to talk about more of that research, like proposals, the projects that you're working on with your undergraduate students. We teased it a little bit in the intro, but I want to dive deeper into what you're researching at the University of Utah. So what are you specifically researching at the University of Utah, and what has been the most interesting find so far for you?
Yeah, that's a great question. My research focuses generally on extreme weather and climate. So trying to understand how extreme weather events like hurricanes, mid-latitude cyclones, just thunderstorms respond to natural climate variability and anthropogenic climate change. The main tools I use to do my research are models, atmospheric models like climate models, or down to very small scale computer models of individual weather events. A lot of my PhD and postdoc research focused on hurricanes, my original interest. And I mostly focused on hurricane rainfall. How is hurricane rainfall changing due to climate change and why? And during my postdoc and now moving to the University of Utah, I'm broadening out to other types of extreme weather, like extreme precipitation in general. How is that changing? What controls where extreme precipitation happens? Another interesting project that hopefully will get funded will be looking at forecasting the risk of flash flooding in southern Utah, which is a really remote region with a lot of national parks. It's prone to flash flooding in certain areas in the spring and summer. So trying to work with the National Weather Service to hopefully improve their forecasting of flash flooding.
I didn't know that Utah had flooding issues during the spring and summer, as you said. Can you talk about that a little more?
Yeah, it's very specific. So southern Utah is very dry. So it throughout the year does get very little rainfall. But in the late spring and summer, it gets like very small scale thunderstorms associated with the North American monsoon. So basically moisture gets advected over the southwest United States from like the Pacific Ocean mostly. And that moisture, if there's a little bit of like instability and lift, can turn into thunderstorms that are very small scale but can move really quickly. So they're very hard to forecast exactly where they're going to go. And southern Utah also has these structures called slat canyons. So they're very tall, narrow canyons that people like to hike in. And normally that's really cool, but they often have rivers flowing through them. So if a thunderstorm produces a lot of rain at the head of that slat canyon, it can rush down the canyon really quickly and very quickly increase the rate that the river is flowing and the height of the river. It can be very dangerous, especially if it happens to these slat canyons in the national parks that are in southern Utah, where a lot of people visit in the late spring and early summer.
Yeah, I wouldn't want to get caught off guard by that. That sounds pretty extreme. Like just a lot of rain and then all of a sudden the river overflows.
Yeah, it can be very scary and can also like flood roads in the area very quickly. So if you're in your car and you see this flooded road, generally don't drive through it because you don't know how deep it is and the water can be moving really fast. So the National Weather Service does a good job in trying to forecast the best they can how large the risk is for flash floods in those canyons like each day. But again, those thunderstorms are just so hard to forecast. So we're hoping to do some research to try to develop some methods to better be able to forecast those storms.
Interesting. And talking a little bit about that process of getting that project started, and then we can even talk about your current work with tropical cyclone rainfall. What's been the most interesting research find for you so far?
Yeah, that's a great question. So the southern Utah flash flood stuff is still just a proposal. So we're hoping to get funded to do it and do the research a bit more, although it has been started by my colleague at the University of Utah, just from funding he already had. I won't speak to that one now, but I can speak to my research on hurricane rainfall that I did in my PhD and postdoc time. One of the main findings of my PhD, and something I thought was most important, was we expect to see generally an increase in hurricane rainfall with climate change. And that's because we know with climate change, the atmosphere is warming. And as the atmosphere warms, it can actually hold more water in it. So when a hurricane comes through, we expect the hurricane to be able to turn all that extra water into rainfall. And what I was interested in my PhD was we also expect hurricane intensity to increase. Intensity meaning the maximum wind speeds and the maximum upward motion in the hurricane that produces the rainfall. So I was trying to understand how much of the increase in precipitation or rainfall from hurricanes in the future comes from just that increase in moisture in the atmosphere versus an increase in hurricane intensity. And what I found was that actually most of the increase in rainfall from hurricanes actually just comes from the increase in moisture in the atmosphere, and very little of that increase is due to a change in hurricane intensity. And so I think that's important because that means that as climate change continues, even if we don't see a big increase in hurricane intensity, we're still going to continue to see an increase in hurricane rainfall. And researchers have already shown that hurricane rainfall has been increasing, and so it will continue to increase even if the intensity of hurricanes tends to stay the same. And I think that kind of brings up the point that the risk during hurricane landfalls is not solely from the wind speed of the hurricane, which is what we classify the hurricane on, right? Category 1 through 5. That's just based on the wind speed. But actually the most dangerous part of the hurricane and where most of the injuries and deaths come from is water, either from storm surge or from rainfall or both. And so it also gets to the point that we really need to be making sure that people understand that water is the most dangerous part of the hurricane, not the wind speed.
Yeah, and the most recent extreme hurricanes and tropical storms have really highlighted that as well. We had Ida for the Northeast, we had Helene for West North Carolina and the part of the Appalachians. It's extreme the amount of rain those events produced. And this is probably not part of your study because it was done before Ida and Helene. But what were some things from those events that you saw play out as expected based on your research? And then what are some things that may have surprised you about those events?
Yeah, those were really interesting. Helene definitely was really devastating and interesting. I think they both just show what we expect as far as hurricane rainfall increases. Like those storms just dropped an insane amount of rainfall that was going to be pretty impactful no matter what. But especially in the case of Helene, when you drop that rainfall on top of soil that's already saturated from rainfall that have fallen the days before, that's when really things get dangerous, right? That causes landslides and more flash flooding. So both of those cases back up our thought that hurricane rainfall is going to continue to increase and something to be aware of. I think Helene points to maybe the increased research needed on like inland hurricane impacts. I think most of the time when hurricanes are happening, it's the people who live on the coast that are often the most affected. But they're the ones I think that know how to handle usually the storms and when they want to evacuate and they're thinking about hurricane season. I think Helene surprised a lot of people because most of the impacts were in the inland parts of the states. So Western North Carolina and Tennessee, those are people that just aren't as used to potentially having to evacuate and really think about preparing their property for hurricanes and knowing what to do. So maybe we need to put some more research into the risks of inland hurricane flooding and more about those like predecessor rain events that saturate the soils and then you have more rainfall on top of that, which is really dangerous.
Maybe a future research project for you and your students?
Could be, yeah.
It's definitely going to be interesting to see what comes of that research study. And we've even scratched the surface with more of your teaching experience at the University of Utah. We're going to take a quick break right here, but don't go anywhere. We're going to dive into more of that after the break. We'll be right back. Hey there, listeners. Before we get into this segment of On This Day in Weather History, I want to take a moment to talk about Yellow Dog Coffee Roasters, a small local coffee company in my home state of New Jersey that procures some of the best coffee from across the world and freshly roasts it in shop. Now, I'm not being sponsored to talk about Yellow Dog Coffee Roasters, but little known fact, I'm a borderline coffee addict. And I recently went to Yellow Dog Coffee Roasters to get some coffee. And I had such an awesome experience there. I also love local businesses as well. And this local business has a very interesting story, too. The owner, Dave, is a New Jersey native and a former police officer who retired from the service to turn his love for coffee and his small home operation of roasting coffee into a full-time coffee business. And if you're wondering why the name Yellow Dog Coffee Roasters, well, Dave actually named it after his yellow Labrador, Oakley, who accompanies him in the roastery on production days. I actually got to meet Dave and Oakley in their storefront and coffee bar. The atmosphere was welcoming, and more importantly, the coffee was barking good. And you could get some of that barking good coffee delivered to your home by going to yellowdogroaster.com, buy delicious whole bean or pre-ground coffee that's roasted and ground fresh in-house and shipped right to your door. They offer a wide variety of blends and single origin coffees from Colombia, Peru, Ethiopia, and Costa Rica. Now, my personal favorite of those is the Bayman blend, which is a medium roast that I got to try that has some notes of chocolate and blueberry. If you pair that with some milk and some honey syrup, you've got some good coffee to start or continue the day. And don't knock the honey syrup until you've actually tried it. If you order online, you can use code FREE for free shipping on orders over $40. And if you're in the area, you can actually check out their storefront and coffee bar, grab a handcrafted coffee or espresso beverage, and meet the awesome people that make Yellow Dog Coffee a reality, including Oakley. They're located at 420 North Main Street in Manahawkin, New Jersey. The coffee bar offers all of their specialty blends, freshly brewed. They offer a full espresso menu as well, cold brew coffee, and seasonal specialty drinks. If you order online or go to their storefront, make sure you tell them that the Everything Weather podcast sent you. So thank you to Yellow Dog Coffee Roasters for the barking good coffee. And now back to the regularly scheduled program. On this day in weather history, we go back to February 22nd to the 28th of 1969 to one of the most extended and lesser-known winter storms in New England's history. On February 22nd, a low-pressure system offshore of Louisiana and Alabama was gearing up to take a course paralleling the eastern coast of the United States. By the 23rd, it was offshore of the Carolinas and beginning to track north. As it was bringing light snow to parts of the Appalachian Mountains and into the mid-Atlantic United States. On the 24th, the system strengthened into a full-fledged nor'easter and began to bring snow to parts of the northeastern United States. Much of the snow fell for parts of New England, stretching from Rhode Island and Connecticut to Maine. The nor'easter then stalled off the coast of Maine, bringing bands of heavy snow to New England for days. However, the nor'easter began to weaken and shift out to sea by February 28th. Because the nor'easter brought days of snow, many locations across New England reported massive snow totals. Mount Washington, New Hampshire received just under 100 inches of snow, or around 8 feet. Almost half of that snow, 49.3 inches, fell on February 25th at the summit of Mount Washington. This set a record for the most snow to fall in 24 hours for New England, and the most snow ever recorded from a single storm for the region. The storm also led to the deepest snowpack on record for New England, meaning the total snow on the ground from this storm and from prior winter storms. That record, which stands at 164 inches, or over 13 feet of snow, was set at Pinkham Notch, New Hampshire. Much of the region saw at least 20 to 30 inches of snow from this storm. This included 38.7 inches being recorded at the Great Blue Hill Observatory, Massachusetts, 28 inches in Concord, New Hampshire, 26.9 inches in Portland, Maine, and 26.3 inches in Boston, Massachusetts. Because the storm brought snow to New England for more than 4 days, it gained the nickname the 100-hour snowstorm of February 1969. Even though the 100-hour snowstorm dropped record-breaking snow across New England, it is not as widely known because most of the heavy snow was away from the heavily populated Northeast corridor. A snowstorm earlier in the month usually gets the most attention when thinking of snowstorms from February 1969. That winter storm was the February 8th or 10th storm, also known as the Lindsay Storm, which crippled the city of New York due to poor preparation for the storm. The 100-hour snowstorm of February 1969, though, still holds numerous snow records across New England to this day. Hello and welcome back to the Everything Weather Podcast. I'm your host, Kyle David, and today we are joined by Dr. Alyssa Stansfield. She's an assistant professor at the University of Utah. She researches tropical cyclone rainfall, climate dynamics, climate change, and she's also mentoring and teaching there as well. We're going to get back into that conversation about her work, things she's learned. But first, I've got another fun game for you, Dr. Stansfield. We've got Would You Rather. So I've got some weather-themed Would You Rather questions. I also have some Utah-themed Would You Rather questions. So we're going to go back and forth between weather and Utah-themed with these. So first up, would you rather be caught outside in a Category 3 hurricane or severe blizzard?
Oh, man. I think I'm going to have to go Category 3 hurricane because at least I'll be warm. I don't want to be shivering outside in a blizzard.
That's good logic there.
Yeah.
Okay. All right. Would you rather hike Angel's Landing in Zion National Park or Delicate Arch in Arches National Park?
Ooh. So I've actually done one of those. I've done Delicate Arch, and it was really cool. And so I've never done Angel's Landing, although I know it's really scary. My sister's done it, and it's like a really narrow, like walkway where you kind of have to hang on to some chains. So that one's pretty scary. Ooh. But I do kind of want to do it, so I'm going to say Angel's Landing.
That's not a fair question because you already did one of those.
Yeah, that's okay.
All right. Would you rather have 100-degree temperatures with high humidity or 20-degree temperatures with strong winds? And for our international listeners, Fahrenheit. 100 Fahrenheit and 20 Fahrenheit.
I mean, you know me. I don't like being cold, so I'm going to have to go the humid and hot.
Really? Okay. Would there be like a threshold that would make you consider otherwise?
Maybe if you're getting like much over 100, maybe I'd start reconsidering, I guess. But yeah, I don't know. I'd rather be hot, really like overheated than cold and shivering.
Yeah, that's fair. I've had a couple of guests say you can take so many layers off, but you can put so many layers on.
Right.
You can put layers on as you can, but you can only take so many off.
That's true. Yeah.
So, all right. Would you rather ski in Park City or, as an alternative, go off-roading in Moab?
Ooh. Those are really cool. And I haven't skied in Park City yet, but it does look really cool because I've seen it from the outside. But Moab also sounds really cool. We're in ski season now, so the temptation of skiing Park City is too much. I'll go skiing Park City.
Skiing Park City. All right. Would you rather chase a tornado in the Great Plains or a hurricane along the Gulf Coast?
Yeah, I've never gotten to go storm chasing. I know people that do it, obviously, but I've just never gotten to go. So I think I'd want to go tornado chasing, actually.
Now, follow-up. Would you rather be one of those storm chasers that goes right into the action or is more step back from the tornado and can see the whole thing?
I think I'd rather step back a little bit. I'd probably be pretty cautious.
That's fair. And you wouldn't want to damage the rental.
No.
All right. Would you rather experience a Utah summer with 100-degree heat or a Utah winter with heavy snow? I have a feeling I know which one you're saying.
Yeah, I mean, I always like the heat. I mean, the snow is nice because that means skiing. But I like when it snows in the mountains. The mountains are right next to Salt Lake City. But sometimes it'll be snowing in the mountains with like no snow in Salt Lake City. So that's the kind of snow I like.
So let's say you have snow in Salt Lake City where you're at.
Yeah, probably the 100-degree. It's a dry heat.
Interesting. Okay. All right. Would you rather have 6 months of constant rain or 6 months of extreme drought?
Oh, man. I mean, kind of like I said in Portland, like 6 months of constant rain sounds really tough. The cloudiness, feel like I need to see the sun. So I guess drought, although it doesn't sound fun either.
Yeah, it's kind of like pick your poison at that point.
Yeah.
All right. Would you rather live by the Great Salt Lake or in the high mountains near Logan?
Yeah, I haven't gone too close to Salt Lake yet. We can see it from our university, actually, and kind of in the distance, but I haven't explored it much yet. And I haven't been to Logan yet either, so that's a good one. Probably Logan. Sounds like a cool spot.
Okay. And I've got one more weather one for you and then one more Utah one. Would you rather be a storm chaser documenting severe weather or a TV meteorologist delivering the forecast?
Well, yeah, I never really wanted to do TV, so I think I'd rather be the first one, the camera person or recording the extreme weather.
The storm chaser?
Storm chaser, yeah.
Okay. Yeah, I think I'd rather do that too, to be honest. And last Utah one. Would you rather see a world-class concert at Red Butte Garden or a Utah Jazz game at Delta Center?
Red Butte Garden. I've been there because it's actually kind of associated with our university and we actually get in for free. I haven't seen a concert there though, so I would love to do that.
All right. Well, I'll make an on-the-fly one. Would you rather do a Utah Jazz game or a Utah Hockey Club game? Because you guys just gained a hockey team out there.
I'm more of a hockey fan, so I'll go to the hockey game.
And you're excited that Utah's got their own team now?
Yep. Yeah, super exciting. I'm excited to see what their name is going to be because they haven't chosen their official name yet, so we'll see.
Yeah, I was wondering that, like why they haven't changed the name yet to a mascot.
Yeah, well, so they were thinking about, I think Yeti was basically chosen, but then they had trouble with the Yeti cooler company. They couldn't reach an agreement about trademarks or whatever. So now I think it's between keeping Utah Hockey Club, which I'm not a fan of, or the Utah Mammoth or the Utah Outlaws are the two other choices. I kind of like both of those.
Utah Outlaws sounds like XFL team, like the United Football League team.
Yeah, kind of.
All right. Well, that's our last Would You Rather question. So let's get back into our conversation about you, your work, all the things that you do at the University of Utah. And we touched upon it a little bit earlier, but you mentioned you wear a lot of different hats. You are a researcher, you're an educator, you're a mentor, and you're also a scientist as well, who's specialized in a certain area in meteorology. What part of your work in wearing all those different hats brings you the most joy or fulfillment, and why?
Yeah, that's a great question. And I will say wearing the hats is hard. It is a lot of work, but I do think it's worth it because I really do like my job so far. I would say one of my favorite things is that I'm always learning, and my job is to learn, basically. So my job is to come up with research ideas, go to seminars in my department, learn about what my colleagues are researching, both in my department and at the university and beyond the university. Learn from my students. They ask great questions, and I learn a lot from them and what they're researching. I just like learning about new things. I think it keeps things exciting. That's a part of my job I really enjoy. I also, like I said, I really like mentoring and working with students. I find it really rewarding. I like teaching the students about meteorology, atmospheric science, climate science, and seeing them learn new things. I like mentoring and getting people experienced with research and seeing what research is like, and then also trying to help them figure out what career they want to try to pursue, whether that's National Weather Service or working in the private sector or being an academic. I try to help people find what they're passionate about so they can go to the career that they will enjoy the most.
And on that note, what has been the most rewarding experience mentoring students, and then what's been the most challenging experience for you mentoring students?
Yeah, I'm still pretty new at this, so I'm sure if you asked me in a year, I'd probably have totally new answers. But I'll give my answers as they are now. I think the most rewarding or my favorite part with teaching and mentoring students is just really seeing them understand something really well that they didn't understand before. So I think in class, that's the most obvious, when they didn't do so well on the homework, and then I give a similar question on the exam and they get 10 out of 10 and they do really well. So I think seeing people actively learn and understand things that they didn't know is really rewarding. The hardest part, it's tough. I think the hardest part mentoring students is just the uncertainty around federal funding for climate research right now, because I want them to pursue what they find most interesting and what they're passionate about. And there's just a lot of uncertainty in the federal funding situation, especially about climate change. I think it's hard to talk about that with them, and it's hard to mentor when you're so uncertain about things as well. So that's a very current topical one, but that's what's been on my mind about that recently.
Yeah, it's unfortunate to hear that policies have changed access to funding and grants for research, because research is important, not just for the weather and meteorology, but every walk of life, learning things and bettering life as well.
Mm-hmm. Yeah, no, totally agree. And research is important. It returns so much to the economy and gives people jobs and makes so many amazing advances, not only in our field, but all the fields and medical fields. And not even just research, is like the National Weather Service is a federal good here in the US, and the return on investment to the National Weather Service is insane. They save so many lives, they help so many people, and I really feel like they are underappreciated sometimes. Give them some love and know that it's hard right now when you don't feel like people are valuing you as much as they should for all the hard work they put in.
Big shout out to all the people in the National Weather Service, NOAA, and the emergency management people who are
Totally
doing critical work minute by minute with weather events. And going back to what you said earlier about all of the different applications of research, I'm curious, what's been the most surprising application for your research or anything that you've worked on?
I feel like a lot of my PhD research and postdoc research has been theoretical and idealized, so it wasn't like super applied. Although I did early on in grad school, I was involved in a project with my PhD advisor and a couple other scientists where we did the first like public climate change attribution of a hurricane. So that was Hurricane Florence back in 2018. Before the hurricane even hit land, we were running these model simulations of Hurricane Florence and trying to understand how climate change impacted the hurricane. Because we know, as we said, it's impacting rainfall, maybe the intensity of the storm. And so basically, we run a simulation of Hurricane Florence as it actually happened in the climate conditions that were in 2018. And then we can run a simulation of Hurricane Florence under climate conditions as they were in like 1850, so before major anthropogenic climate change. And then we compare those two model simulations and can estimate how much climate change since 1850 impacted Hurricane Florence. So we found that its rainfall was definitely increased, not too much of a signal in the intensity, but definitely in rainfall. That ended up getting a lot of media attention because it was a really new method at the time. And since then, it's been done on many more hurricanes, and the technique and methodology have developed a lot. And so it's a lot better now. That was interesting to be a brand new grad student. I think that was in my second year of grad school, and kind of be involved in this study that got so much media coverage and attention.
Now, I'm curious, were you interviewed at all for like a publication or?
I was not. My advisor definitely was, because he was the lead on the study. And I think he probably shielded me a little bit from the media coverage, because media coverage can be a lot. It can be really positive, which a lot of it was, but it also opens you up to a lot of criticism and climate change deniers and people that kind of want to discredit you and stuff. He led the study and it was like his idea, so he should be really the one being interviewed and stuff. But I think he also purposefully shielded me a little bit from that, because he didn't want me to get the negative impacts that sometimes come with media coverage.
Definitely. And you bring up an interesting point, too, that your mentor shielded you from the media, not just because it could be a little scrutinous, but also the amount of climate change deniers or skeptics that will challenge you and your work. And since you've done work with climate dynamics, climate change, and how that connects to tropical weather, I'm curious, how do you communicate that the climate is changing and happening and how that shows in your work?
It's really difficult. And this is something that particularly interests me, like climate communication to the public. And I think what I've learned, and I've taken some classes and seminars on this topic, like science communication, climate communication. I think the key is trying to relate climate change and its impacts to people's specific lives. That's the most effective way to get them to care. So, for example, if someone is a farmer, you can bring up, have you been seeing more droughts recently in your area? And then talking to them about that and making it a dialogue. So a two-way dialogue, right? No one likes to be lectured at, and people will probably tune out and not listen. So I think making it a dialogue, learning what people care about and what their values are, and then tailoring your message to that. And I think it's important to know, too, that some people are unreachable. Some people are so deep in it that you're not going to be able to change their mind. And that's not a flaw on you. It's okay. But I think there are a lot of people that can be woken up to this stuff, and maybe after they do experience an event like Hurricane Helene, they're more open, like, wow, this kind of stuff didn't used to happen when I was younger. Why is this happening more often? So it's a really tough problem. I think one of the biggest threats to science, and our science specifically, is like these kind of targeted misinformation and disinformation campaigns that is like purposefully spreading false information. And it's really hard to counter that stuff because it's a lot easier to spread lies than it is to try to correct the people to the truth, unfortunately.
Yeah, and I feel like they kind of design it in a way to make it go viral easy because you have certain elements that are used, and that catches on more than the person telling the truth and giving an honest forecast or honest information.
Right.
But going back to your teaching experience, I'm just curious because you're the first teacher that I've had, or somebody who has teaching experience. What's been the best question that you've been asked by a student that made you go, ooh, that's a good question? And then what's one question that I don't want to say is a bad question, but maybe like a funny question or an unusual question?
That's a good question. So this is my first semester teaching. I'm teaching a graduate level climate dynamics class. So I have all our first year grad students in our department, and they ask really good questions. They ask questions that I don't know the answer to, that I have to say, I don't know. I'm going to go look that up, and maybe I can give you an answer or show you a paper, maybe point you to a paper that can help us get the answer, or maybe there is no answer. Like, 'cause sometimes people ask questions, it's like, wow, we don't actually know that. That would be a good research project. I will say that another interesting thing about teaching is you do get people that have different experiences. So in our atmospheric science program, we have people who come in with bachelor degrees in meteorology and atmospheric science, but also physics and math. And in my graduate course this year, I actually have people who have a background in like nuclear engineering and geology. So it's really interesting to see what perspectives those students bring in and what kind of questions they're asking about atmospheric science and meteorology and climate, because that's not what they've taken classes on before. I think that makes me a better teacher because I have to think about how can I present this information in a way that is accessible to all these people with different backgrounds.
So you said nuclear physics and geology.
Yeah, geology and then nuclear engineering.
Okay, that surprised me. And on that note, did that surprise you, or is there another background that interests you?
Oh, well, yeah, I was surprised that there were people, the grad students outside our department that were taking the class, because this is usually a class, I think it's usually just made of our atmospheric science graduate students. So it's interesting to see, like, yeah, who else was interested in the class and why they wanted to take it.
Interesting. I'm still trying to picture how nuclear engineering connects to climate dynamics.
I think this person is actually kind of getting a non-thesis based master's. So she's working for a company, and I think whatever she does for the company, they thought, oh, it may be helpful for you to understand more about the atmosphere and how the climate system works.
Interesting. You had mentioned earlier that some of the questions that you've been asked, you may not know the answers to, and you it said, oh, maybe that could make an interesting research question or a research project in the future. What are some emerging research questions that are coming out right now, and what are some questions and projects that particularly excite you right now?
Yeah, that's a great question. There's a lot of exciting research going on in the field in general and at Utah and elsewhere. I think something I'm interested in and hoping to get into is a little bit more on the impacts of extreme weather on society and the environment. So particularly the impacts of precipitation and extreme rainfall. Can we predict better where this flooding is going to happen and how the flooding is going to change with climate change? Because understanding how rainfall is going to change is really interesting and helpful, but it's really the flooding that actually impacts people on the ground. So making our predictions of that better, of those actual impacts, I think is something I'm interested in getting into. And that could be pretty interdisciplinary. So like I may want to try working with someone who's like a hydrologist because they understand flooding and rivers and water transport way more than I do. I come at it more from the atmosphere and rainfall. So maybe doing some like atmosphere hydrology modeling would be super cool. Another project I am hoping to get funded for that I think is really exciting is actually looking at the increasing risk of extreme heat after hurricane landfalls in the southeast US. So Hurricane Beryl last year was an example of this, where a hurricane comes through and often it knocks out power for at least a couple days. And so if the hurricane is followed up by a heat wave and people don't have power, that really increases hospital visits and fatalities and damages from the storm. And so the southeast of the U.S. is obviously has hurricane landfalls almost every year and are also pretty at risk for heat waves. And so trying to understand how the risk of what are called compound events, so hurricane landfall plus heat wave is an example of a compound event, how those may change in the future is really interesting. And I think that compound events are really kind of a hot topic in the field in general. So extreme heat and drought together is like a compound event. Extreme winds plus flooding or rainfall from a hurricane is like a compound event. So two events that on their own may be damaging, but then when you put them together, the damage kind of multiplies. That's something that the field is really interested in now.
And you said you're potentially going to research that a little more?
Hopefully, yeah. I put in a grant proposal, so hopefully if it gets funded, I'll be able to research that.
And then we'll have to have you back on. We could talk about that a little more, because that in itself is interesting.
Yeah, it's emerging. There's been a little bit of research on it so far, but not too much. I really hope I get funded and can do it, because I think it's a really interesting and really important topic.
Definitely. And just to go back a couple steps in our conversation a little bit, we talked about different approaches, different backgrounds, studying meteorology, studying different things. And I'm curious, how do you see research roles, experiences evolving for students as meteorology becomes more interdisciplinary, like with different backgrounds, like nuclear engineering, as you mentioned?
Yeah, that's a really good question. I think interdisciplinary research and interdisciplinary experience is definitely becoming more valued, as I think it should be. For students, maybe that means trying to branch out a little bit when you're taking your classes, and maybe if there's something topic that you're interested in, maybe take a couple classes in it or do a minor if you can. If you do meteorology, take some hydrology classes if they have it at your university. Or maybe I know someone who majored in like meteorology and business because they wanted to, maybe build some technology or start a business related to like weather and meteorology. So I think interdisciplinary stuff is definitely becoming more prevalent. I think it's super useful in many different careers. Just taking the opportunities to have all these skills across disciplines when you can, I think is important. Science communication, that's an interdisciplinary thing, right? If you're a scientist, but you really are passionate about communicating to the public, try to take some public speaking and communication classes, get that experience.
And on that note, for anybody who may be listening who wants to go into grad school or pursue research, maybe not just in meteorology, but in general, what trends or emerging fields do you think they should be paying attention to right now?
With grad school, it's kind of like anything you're interested in. I think people do research in like all kinds of different stuff. It's just about finding the school and advisor that interests you. But AI and machine learning is definitely a trend in the field right now that a lot of people are interested in researching. So that's definitely something that's emerging. Like interdisciplinary research, I think there's more and more people doing that. I think 20 years ago, it'd be hard to find a meteorologist, atmospheric scientist doing really interdisciplinary research. It was just a lot more rare. I think it's becoming a lot more common generally.
And on the note of AI is like a very hot topic nowadays. It's being incorporated in not just meteorology things, but all different industries and stuff. And I'm curious, what do you think are some of the opportunities or risks that you foresee for using AI in studying extreme weather events or just in the research field in general?
Yeah, that's a topic we could probably have like 3 more podcasts on, honestly.
Probably, yeah.
It's very interesting. And I've been learning a little more and more about like machine learning because it is such a big topic and there's federal funding for it as well. Yeah, there's a lot of opportunities. I think machine learning techniques have actually been in the field for a while. I think they just weren't called machine learning back then. It was just K-means clustering, and clustering stuff was always used for a while. But now it's fancy and new machine learning, which is fine. The AI specifically, like, I don't know as much about. I'm sure there's a lot of opportunities, though. I think generally thinking about my research in my field and AI and machine learning, a big challenge is computers can only learn from the data you give it. And we only have a limited amount of data in our field. We only have the weather and climate data going back. In the US, we have pretty long records at the ground. But satellites only go back to the 1970s or so. And when you're researching extreme events, well, extreme events are rare by definition. So we don't have that many examples of them. So a big challenge in machine learning and AI stuff in climate change research is, well, you're training the computer models, the AI, the machine learning on past data that we have, but we don't really know if that applies to our future climate. We know the climate is changing, our weather, and so many things about the climate system. And so how do we know that training these models on past data, they're going to make good predictions for the future? To be honest, they're probably not. And so trying to correct for that maybe is one interesting avenue in machine learning and AI research that's relevant to our field.
Yeah, I mean, kind of to go back what you said about the data, if you have iffy data going in, you get iffy data coming out.
Right. And we only can train it on what we have, and we're kind of extrapolating into the future. It's like making predictions on stuff it hasn't seen before, and we don't really know that computers do that well on that.
Yeah, it's going to be interesting to see how things unfold in that area. But going back in time now, you've had a whole bunch of career experiences, and looking back now, what's one piece of advice that you would offer to a younger you or somebody who is in the same shoes as you once were?
Yeah, that's a great question. I think what I came up with is that expertise is really built over time. When I was just starting out, maybe as an undergrad, or when I was first starting my research as an undergrad, I think I was frustrated and like so much I didn't know and didn't understand because I was just starting my education. And learning and building up that knowledge takes a lot of time. Like the professors that we learn from and the professors in my department that are more experienced than me, they've been doing this for so long. They have so much experience. They've taught these classes so many times. So you're going to make mistakes at first and you're not going to understand things. And that's okay because everyone is like that. Like coming up with great ideas and learning concepts, yeah, it just takes time and repetition. So like, I feel like I am teaching my climate dynamics class, and I feel like I'm almost now fully understanding some of these topics that I first learned about in grad school, but I feel like I really didn't understand them that well. And now after thinking about them and learning about them multiple times, now I'm like, oh, okay, I like really understand what this means now. As I said, expertise is built over time and repetition. Be patient, don't get frustrated, and maybe lean on the people around you who do have a lot of experience. So for me, that's the professors in my department who are more senior and have been doing this job for a long time. For people at the Weather Service, that's those forecasters that have been working there for 20 years and have so much experience, and learn from them and ask questions. And yeah, just know that everyone feels like unsure and makes mistakes, especially when you're first starting.
Definitely some good advice there. Well, Dr. Stansfield, I got one more little segment for you before we get into our whether or not trivia. I leave the floor open to you. Is there any myths that you want to bust? Some questions that I haven't asked that you want to touch upon? Any other final parting thoughts?
Yeah, I think I'm going to comment on we talked a little bit about our just like current situation with the federal government and kind of general doubt in government workers and people who do research on climate and so many other topics. Is that I think the majority of people know what good work you do and how important you are. And it's really easy to get distracted by the negative comments and hate. And I think we know how important the research and the work is. And so just keep doing it as much as you can. Don't give up. We need people making great forecasts and helping out in emergencies and communicating science to the public and doing the things they're passionate about. I think this is like advice to maybe myself and to a lot of people out there. It's just like, yeah, don't give up and keep doing what you're passionate about.
Those are some very good parting thoughts there. Well, Dr. Stansfield, that is the last question, but not the end of the interview. We still have our whether or not trivia. This is the fun game where I get to ask you some weather-themed and non-weather themed trivia questions. With that said, are you ready to get into it?
I think so. Let's see how this goes.
All right. Let's kick it off. This is whether or not. First question is related to Avatar: The Last Airbender. Which nickname was given to the character Iroh? Is it A, the Breath of the North, B, the Emperor of the East, C, the Dragon of the West, or D, the Son of the South?
Ooh, I know this one. It is C, the Dragon of the West.
Final guess?
Yes.
You are correct. It is the Dragon of the West. Love that character, by the way, and I love that show.
He may be my favorite character. Yeah, I recently, so I watched that show back when it was like first premiering on Nickelodeon. I don't remember how old I was. And then I was so excited when it came on Netflix again, because I feel like so many more people watched it. And I watched the whole thing again, like 2 or 3 times. So I've seen it quite a few times.
I think I saw it a few times when I had the DVDs in our house for the TV show. And I got to watch that again on Netflix at some point.
Yeah.
But, all right, got that one. Next up. This is whether or not your next question is related to tropical weather. Which hurricane season holds the record for most tropical storms in a hurricane season in the Atlantic? Is it A, 1933, B, 2021, C, 2005, or D, 2020?
So the most tropical storms.
Yes.
Oh, I mean, 2020 has the most storms altogether, I'm pretty sure now. So I'm going to guess 2020. I just feel like that's maybe the most educated guess.
Final guess 2020?
Yeah.
You are correct. It is 2020 with 30 tropical storms.
Wow. Yeah, that was a crazy year. I remember how record-breaking 2020 was. 2020 was, and it's almost like hard to keep track of all the storms for so many of them.
It went Greek too.
Yeah, I remember it went into the Greek characters.
All right. This is whether or not your next question is related to Olympic volleyball. Which country won the first women's volleyball gold medal at the 1964 Tokyo Olympics? Was it A, the Soviet Union, B, the United States, C, China, or D, Japan?
That's a tough one. I mean, those teams are all pretty good at volleyball, women's volleyball. Back in, what year was it?
1964 at the
64.
Tokyo Olympics.
I want to hope it was the U.S., but I'm not sure if that's my guess. I'm going to guess the Soviet Union.
Final guess?
Yeah.
You are incorrect. It was Japan.
Japan. Oh, the home team. Okay.
Yeah, I don't think that's happened too many times in Olympic history.
Yeah, that's pretty rare.
Yeah, interesting. All right. This is whether or not your next question is related to mountain weather. What is the correct definition for a Chinook wind? Is it A, a cold, wet wind that brings heavy snowfall to mountain areas? B, a warm, dry wind that descends the eastern slopes of mountain ranges, often melting snow rapidly? C, a type of thunderstorm common in the Rocky Mountains? Or D, a high-altitude jet stream that affects air travel over the mountains?
I know it's a wind coming down the mountain. I think it's the warm, dry wind. So I think that was B.
Final guess is B, warm, dry wind?
Yeah.
You are correct. It is a warm, dry wind that descends the eastern slope of the mountains. All right. This is whether or not your next question is related to Rockies hiking. What is the name of the highest continuous paved road in North America that passes through Rocky Mountain National Park? Is it A, Peak to Peak Highway, B, Trail Ridge Road, C, Mount Evans Scenic Byway, or D, Pikes Peak Highway?
It's either B or C, but you mentioned Rocky Mountain National Park, and I know Trail Ridge Road is in Rocky Mountain National Park. So I think I'm going to go B.
Final guess is Trail Ridge Road?
Yeah.
You are correct. It is Trail Ridge Road.
Nice.
And with that, that is the last whether or not trivia question and the end of our conversation. But before we go, how can people stay in touch with you and the awesome work that you're doing, Dr. Stansfield?
Oh, yeah. So my email. So if you want to contact me, my email is alyssa.stansfield@utah.edu. That's the best way to contact me. I also have a website that kind of goes through my research and has my papers I've published and stuff. So that website is alyssa-stansfield.github.io.
And we'll make sure to include your email and your GitHub page in the show notes for everybody to go and find that. Well, Dr. Stansfield, thank you so much for coming on to the podcast, and thank you to the listener for listening to the Everything Weather podcast. And we'll catch you on the next episode.
Thanks so much.